Right, question 5 starts off with a bit of multiplying. So, first of all, I want to find out what w squared is. So 1 plus 2i squared, remembering that is double brackets. And then just multiply that out. So that's 1 plus 2i plus 2i is 4i plus 4i squared. So I squared is -1, so that's going to be 1 plus 4i, take away 4, so -3 plus 4i. Okay. Now, if we can check this, obviously, in the calculator, 1 plus 2i squared. There we go. Right, say we then wanted w cubed, we can use our answer to help us. So that's 1 plus 2i times w squared, which we've already worked out. Okay. So however you multiply that out, so it's going to be -3 take away 6i plus 4i plus 8i squared. I always write down the I squared, so it's very easy to get the signs wrong if you don't. So that's take away 8, so that's -11, and take away 2i. Similarly for w4, so that's w cubed times another 1 plus 2i, so -11, take away 2i, take away 22i, take away 4i squared, so it's going to be plus 4, so -11 plus 4, -7, take away 24i. Again, very easy to check these, so we just go back in our calculators, change a squared to a 3, you can see we've got that right, go back, change a cube to a 4, and okay. Right, second part. So we know that w is a root of this equation. Now that means therefore it must fulfill that equation. Now helpfully you'll notice we've got to do our root to the power of 4, our root cubed, our root squared, etc., which we've already worked out in part A. So if I'm going to put w into that equation, we're going to get w to the 4 plus p, w cubed plus q, w squared minus 6w plus 65 equals 0. So let's put that in. Right, notice in this one that the right hand side of the equation is 0, which means the real parts and the imaginary parts on the left hand side of this equation must both equal 0. Once I've got my simultaneous equations, I've just rewritten them so that I can use the equation solver on the calculator. So simultaneous equations, 2 unknowns. Oops, put the numbers in. Okay, the question wants to find the values of p and q. So p is 2, q is 10. You could check that by putting them back into the equation and getting your calculator to solve the quartic.